Here's the multiple comparison problem. Suppose I conduct one test, and the type 1 error rate of that test is 0.05, and we typically call that alpha. In other words, I've set up my test such that when the null hypothesis is true, there is only a 5% chance I'll accidentally reject that null hypothesis. So the probability I'll make that type of error, that I'll reject the null hypothesis when it's actually true, is 5%. So I'll do one test. Now my friend does a different test on a totally different topic, and her test also has a 5% probability of making this type of error. And then another friend does another test on a different data set, and the probability that she makes this type of error is 5%. If you put all three of us together, the probability that at least one of us made a mistake is higher than 5%. If I have several tests, the probability I make at least one mistake is 5%. Similarly, if the probability that a confidence interval covers a true value is 95%, then if me and all my friends make confidence intervals, the probability that we're all going to cover the true value is less than 95% because we each have a 5% error rate. Even for one research project that I might conduct, if I ask a whole lot of different questions and each of my answers to those questions comes with a 5% error rate, the probability that I'm going to make at least one mistake gets higher and higher. So here's some calculations to help drive that point home. Suppose that I calculate just one confidence interval to answer one question. The probability that that interval covers a true value is 95% because I set it up that way. But now suppose independently I make another interval. I have two independent intervals. The probability that both those intervals are going to cover the true values has gone down a little bit. You can see as I increase the number of different independent confidence intervals that I create, the probability that all of the confidence intervals cover the true value goes down. If you ask, say, 10 different questions and create 10 different confidence intervals for your research project, you're at a 60% probability that all those intervals are actually covering the true value.